You've seen the explanation on how UV spectrometry works. Now let's move on to know how the experiment was carried out. The aim for this experiment is to determine the type of beverage in each sample by measuring the concentration of caffeine in the samples. There are 4 sets of data to be tested for this experiment. The first one is calibration. You must be wondering, what is the purpose of doing calibration? The purpose is to determine and compare the concentration of caffeine of the known solution can be called as standard with the unknown concentration called as samples. Hence, the type of beverage can be concluded based on the concentration of the samples. Calibration was carried out by dissolving pure caffeine standard in the ionized water to reach a certain value of concentration consists of 0 ppm, which is the blank sample and only contains the ionized water, a concentration of 10 ppm, 20 ppm, 30, 40, as well as 100 ppm also prepared to determine the concentration of the samples. The second set of experiment was to test a set of samples without dilution, followed with samples which were prepared at 10 times dilution and 50 times dilution. How can this dilution be done? It was done by adding the sample solution with the ionized water as mentioned earlier. There were 5 samples included sourced from the following beverages, which are instant coffee, black tea, green tea, decaffeinated coffee, and pressed coffee. Now let's take a look at the results obtained from those 4 sets of experiment. Here is the calibration data that was obtained from the experiment. The absorbance of each standard also recorded, indicated as AU, which later will be used to plot a graph of absorbance versus concentration. The wavelength corresponding to the caffeine interest is taken to be at 269.10 nanometers, and the concentration is in ppm. The concentration of caffeine and absorbance are presented in average concentration and average absorbance since the experiment was recorded twice. A set of samples without dilution is presented in table as seen, with the lowest concentration at 23.28 ppm and with the highest concentration of 105.88 ppm. In this set of experiment, the 5 samples are labeled as U1 to U5. Following with the data obtained from a set of samples with 10 times dilution, it shows a decreasing in average concentration of caffeine and absorbance compared to the data obtained from sample without dilutions. The samples in this set of experiment are labeled as V1 to V5. A set of samples with 50 times dilution shows even lower number in terms of average concentration of caffeine and average absorbance, and the samples in this set of experiment are labeled as W1 to W5. The data obtained from those 4 sets of samples are plotted in absorbance versus concentration graph, where different colors of the point indicate different set of samples. Standard data is presented by blue points, sample without dilution is presented in red points, as well as sample with 10 times and 50 times dilutions are presented in gray and yellow points respectively. Here we come to the discussion part to analyze the accuracy of data obtained from the experiment. The first discussion will be commenting on the linearity of the calibration graph. As seen in the graph, absorbance values versus concentration of caffeine for a standard is plotted. The line has an equation of y equals to 0.0619x minus 0.2324 with r-squared value of 0.9838. R-squared is the square of the correlation coefficient and provides information about how far away the y values are from the predicted line. A perfect line would have an r-squared value of 1, and most r-squared values for calibration curves are over 0.95. Since the r-squared value of this graph is 0.9838, which is above 0.95, it can be said that this calibration graph is linear in terms of the sensitivity of the measurement, and it follows Beer-Lambert law rule. The second discussion is about the accuracy of the calibration data. What if different concentration of standards were prepared? For example, as opposed to the value used in the experiment, will the calibration graph be the same? The answer is the calibration graph will be different. To answer this question, let's look at the calibration graph along with no dilution samples plotted. The reported linear concentration range is 0 to 100 ppm. and the average concentration of caffeine from the samples without dilution lies within the line between 23 to 105 ppm. If the concentration of standards were prepared differently, let's say 100 ppm as the lowest concentration, then this can lead to non-linear response of the graph, since the concentration of samples without dilution recorded will not fall within the range of the reported line, and the data obtained from the samples will not be accurate.
We will be determining what type of beverage the samples are. Next, we'll be learning how did we determine the type of beverage for the sample. Well, first we would compare our data with the data obtained from the literature, and then obviously we would see if there's any similarities, and then based on that, that is how we determine the samples. After we know how to determine what the samples are, and then we finally get the answers where A is decaffeinated coffee, B is pressed coffee, C is instant coffee, D is black coffee, and finally E is green tea. Now, like the lady's face, we'll be wondering what are the effects of dilution, and based on the results shown earlier, we can tell that dilution further reduces the concentration of the sample. And yes, discrepancies were expected in this experiment, but you would be wondering, but why? Well, this is due to the fact that a volumetric flask wasn't used to have a proper mixing, and the mixing method obviously was wrong as well. Not to mention that the pipette tip, mechanical pipette tip, was reused, so it was washed. And there are possibilities that when it was washed, it didn't fully get decontaminated, hence contamination is possible, and you would know by then that that would probably cause errors as well. Next, we'll be moving on to the possible sources of errors and how to overcome them. In terms of standard deviation, the highest standard deviation obtained was 3.725, and that was for U2. The cause of the deviation is most likely due to the preparation of samples not being done properly, as parallax error is bound to happen. Adding on, the time in which the samples were planned or obtained is unsure, hence it was left in the lab for a long duration. It can be said that this would affect the concentration of the sample due to the temperature dropping. These are the values without dilution. As you can see, the standard deviation at its peak is at U2 as stated. And as you can see, this is 10 times dilution, and the standard deviation is very minimal, and that is what we should strive to obtain. This is 50 times dilution, and the standard deviation is at its most minimal comparing to the other two data values that were obtained. One way for overcoming the errors is to use proper equipment, like we used mechanical pipettes, and that would help reduce the possibility of errors. Hence, in a way, more accurate equipment will obviously help reduce the errors. And another thing is to have a fixed person reading the measurements, as other people might perceive the data totally differently. Now, a more efficient way in terms of accuracy for the experiment is that when pouring the sample, burette should be utilized. In this experiment, it wasn't. That's why that might have caused the deviations in the no dilution data. Now we'll be moving on to the suggested analytical method, which is totally different from what we did for caffeine. As you can see, this is a ATR FTIR, which stands for Attenuated Total Reflectance Fourier Transform Infrared Spectroscopy. This is suggested because mainly it is more cost effective, and not to mention that it's faster and as well as more accurate in comparison with two other methods which will be shown later. And the reasoning of why the FTIR was chosen instead is because it is more accurate in terms of reading, as can be seen in the comparison with the NIR and the fluorescence spectroscopy.